Grade 11 learners, let us continue with the analytical geometry. Yeah, we are done with the formula for the distance and the midpoint. I want us to get into another formula for the gradient. Let me draw a line again. Line. Okay. Right. It's a line. And on the line, let me have point A, which is X at A, and the Y at A. Let me have again a point there on the line, point B, which is X at B and Y at B. Now, if you are requested to find the gradient of this line where you are having 2 points, immediately we bring another point here. Let's have this point as E, for example, which is X at E and the Y at E. Okay. The gradient of, look, we're also using the M. The gradient of AB is equals to the change in Y, which is the Y at B minus the Y at A divided by X at B minus X at A. So this is the formula for the gradient of the line. Remember, people, you might also find the gradient AE. The gradient AE. The formula is Y at E minus the Y at A divided by the X at E minus the X at A. All right. Now this is the gradient of this line. It's still the same. And you might sometimes requested to find the gradient EB. The gradient of E. Oh, I'm sorry there. EB is equals to the Y at B minus the Y at E divided by the X at B minus the X at E. I think you can see that when I'm starting with the B, I'm at the top, I'm also doing the same at the bottom. And remember, people, if you find that the gradient, if the gradient AB is equals to the gradient AE, and is also equals to the gradient E, the gradient EB, then you call A, A, E, B points of collinear. Okay, here is it, collinear. Do you see it? Collinear. If the gradient of AB is equals to the gradient of BC is equals to the gradient of AC, then those points, we call them collinear points. Collinear points. Okay. Now, people, let us look at one of the exercises that you are given. All right, let me go back. I just want to use any of the points. Let's take, for instance, we are using this ones here. Okay, let's use 4.2. Let's use 4.2. 4.2. I want us to use PQ. PQ is -2 and 5. P and Q, all right? Q is 4n minus 1. P is -2 and 5. Q is 4n minus this. Then S is 6 and 3, while T is 2 and 7. Okay. Now, from this given information, I just want to wrap this, people. Let me just wrap these formulas. I hope you have them now with you. Just want to wrap quickly to clean my chalkboard. Clean the chalkboard. Okay. I don't know why it's not cleaning. If you are given point P, you are given point P is -2 and 5. Then you are given point Q is 4 and -1. All right. Then you are also given allow me to wrap this one to clean this chalkboard actually. Let me wrap this also, the line there. Good. What the other point is S, ne? It's S, and the S is 6 and 3, right? And T is 2 and 7, ne? Now let's find the gradient. We are requested to find the gradient PQ, ne? The gradient PQ. You must write the formula. You remember the formula? Y at Q minus Y at P divided by X at Q minus X at P. Y at Q is -1 minus the Y at P is 5 divided by X at Q is 4 minus the X at P is -2. Now let's work this one. Minus there is -6 divided by this one is 6. So -6 plus 6. Okay. So it's 6 over 6 is -1. We are also requested to find the gradient of ST. Look how we deal with this ST. You must write the formula down. The Y at T minus the Y at S divided by the X at T minus the X at S. Alright. How much is the Y at T? Oh, let's look at the Y at T here. Is 7. Put the 7 there. Minus the Y at S is 3. It's 3 there. divided by the x at t is 2 there, minus x at s 6 there. Okay, let's subtract 7 minus minus 3 is 4, divided by minus 4. Then the answer is minus 1. People, if you find the gradient of ST equals to the gradient of PQ, remember these two lines, we call them ST is parallel to PQ. Okay, if the gradient of two lines are equal, then it means the those two lines are also parallel. Let me reveal something that is very important. If you are given the let me reveal this to you. If this line is parallel to this line, and you are given this P and this Q, if you are given PQ and you got the gradient of PQ, you can use this gradient you got here to find the gradient, because they are the same. You don't even need to calculate this gradient, because you know these two lines are parallel. If this line is parallel to this, it means their gradient are also equal. All right. We have dealt with the parallel. I want us to, we have already touched collinear. We don't have to do collinear anymore. We have already touched parallel. We have touched the gradient. I want us to touch perpendicular in the next video. Okay? Yeah. Look at how we explain perpendicular in the next video. Okay, thank you.